Welcome to lesson 6.1, Ratios, Proportions, and the Geometric Mean. So in today's lesson, we're number one, going to look at the idea of solving and writing proportions, then simplifying ratios, and lastly, the geometric mean. Now, I know proportions and ratios are both things that you began with in Algebra 1, so those two parts should be refreshers from previous concepts, and the geometric mean is the new equation that we're introducing with this lesson. So, first thing to start with are a few vocabulary pieces. So in the box over here, we'll look at those. If A and B are two numbers or quantities, and B is not equal to 0, then the ratio of A to B is A over B as a fraction. So simply put, ratios are the same thing as fractions. If we look at example A over here, this would read, the colon reads as the word 2. So this would read as 81 centimeters to 3 centimeters. So that could be written as 81 centimeters over 3 centimeters. That's our first piece of the vocabulary. Then we have the idea of two equal ratios creating a proportion. So an equation that has two ratios that are equal is known as a proportion. In this proportion here, B and C are known as the means, and A and D are known as the extremes. And the reason that those two terms are important is for the geometric mean, we are going to use two of those values. So the geometric mean of two positive numbers, when it's written like a proportion, A and B are in the opposite corners, upper left, bottom right, is this last equation right here. So the geometric mean of A over X equals X over B would simplify to X equals the square root of A times B. So simply put, if we have two numbers, the geometric mean is this equation right here, X equals the square root of AB. And then the last piece of vocabulary that we'll be looking at in this lesson is that property of proportion. And there's more than one property of proportions. We're just looking at one, which is the cross products property, which states if A over B equals C over D, and B and D are not 0, then we can cross multiply, meaning A times D is equal to B times C. So the cross products property, you can multiply diagonally in any proportion. So AD would equal BC. So now let's look at a few examples making sense of these vocabulary terms. So examples on how to simplify ratios. If your ratio is written as a side-by-side, 81 centimeters to 3 centimeters, you first want to write it as a fraction. So we'd write it as 81 centimeters over 3 centimeters. The left goes on top, right on bottom. Then you'd want to divide out the units or cancel the units because they're the same, centimeters and centimeters, and simplify the quantities. 81 over 3 can both be divided by 3, giving us 27 over 1, which is the same thing as 27 to 1, written with the colon. If we already have it as a fraction with the same units, 9 feet over 15 feet, we can simply cancel the units and simplify the 9 over 15 to 3 over 5, or 3 to 5. But what happens if we have different units? If we have different units, like you see here in C, feet and yards, 9 feet over 15 yards, we need to convert if our units are different. So in this case, I'm going to convert both to feet. So 9 feet over 15 yards multiplied by the conversion of 1 yard over 3 feet. What that does is diagonally, my units cancel, yards and yards cancel, feet and feet cancel. So then I'd have 9 over 15 times 3, which is 45, and 9 over 45, both can be divided by 9, giving us 1/5. So if we have different units, you need to convert to make them the same unit. Then the rules follow the same as A and B. And then for our final example, dealing with ratios, we can have what's known as an extended ratio, which is this example here with the triangle. So it says the measures of the angles in triangle ABC are in the extended ratio of 2 to 3 to 5. Find the measures of the angles. So what that tells me is that I'd have a triangle where the ratio is 2 to 3 to 5. So my angles would be 2x, 3x, and 5x. So what we know is the 3 interior angles of a triangle all add to be 180. So 2x plus 3x plus 5x equals 180. 2 plus 3 plus 5 is 10x. So 10x equals 180, meaning x equals 18. Then, once we add 18 for the value of x to find the measure of the angles, we would do 2 times 18 for 36, 3 times 18 for angle B down here, which is 54 degrees, and for angle C, 5 times x, or 5 times 18, which is 90 degrees. All right. Then, after the idea of ratios, we get into proportions, which is one ratio equal to another, or a fraction equal to a fraction. So in order to solve a proportion, we can simplify the steps in the rules to cross multiply, then divide. Meaning if we have x over 8 equals 5 over 4, we want to cross multiply first. So 4 times x and 8 times 5, which would give us 4x equals 40. Then we want to divide by whatever is attached to our variable. So divide both by 4, and x would equal 10. So to solve a proportion, you're using the cross products property, cross multiply, and then divide by whatever number is attached to the variable. So if we have a over 12 equals 5/3, cross multiply, 3 times a equals 12 times 5. So 3a equals 60, divide by the 3, and a equals 20. In B down here, 9 over y equals 3 over 7. So 3 times y equals 9 times 7. 3y equals 63. Divide both sides by the 3 to get y alone, and y equals 21. So for any proportion, cross multiply and then divide to get the variable alone. And then our last examples is looking at that idea of a geometric mean. So if we wanted to start with the example over here, find the geometric mean of 45 and 5. So our equation is x equals the square root of a times b. 45 and 5 are our a and b. So it's simply x equals the square root of 45 times 5, which is the square root of 225. And the square root of 225 is 15. So the geometric mean of 45 and 5 is 15. So find the geometric mean of 3 and 27. In this case, x equals square root of 3 times 27. So x is the square root of 81. Square root of 81 is 9. Geometric mean of 6 and 15. So x equals square root of 6 times 15, which is the square root of 90. And the square root of 90 is approximately 9.5. So for geometric mean, you want to remember this equation: x equals the square root of the two numbers multiplied together.